Hi, in today's tutorial we are going to classify chess pieces. We are going to use dataset of chess images, and we are going to use TensorFlow and CNN methodology in order to classify these pieces. So first of all, we are going to install the relevant Python libraries, and the next step we are going to download the dataset from Kaggle website. So we are going to create a content environment. We'll call it chess CNN, and we are going to use Python 3.7. I will leave in my GitHub a text file with all this installation, these guidelines, and all these pip install commands. Basically, we have to install TensorFlow, GPU, OpenCV, and some more Python libraries. So please follow the first step. It is an installation step, a very straightforward process. Okay, now we are ready to download the dataset. We are going to the Kaggle website, and we're going to search for chess and look for the relevant dataset. It's called chess main image dataset. Please watch we have 6 categories, and in each category we have several hundreds of images. This is, for example, bishop images. Each image has its own dimensions. This is king. There is a knight images as well, queen and rook. So we are going to download this dataset. It's a zip file. We are going to extract it and copy the dataset to our working directory. Okay, so we download the images. You can watch them, evaluate them. Okay, the first program will be building folders. That means instead of building it manually using our operation system, we are going to code it. So first, let's choose the relevant content environment, the one that we created before. And now we are going to code a simple code, Python code, that will create the training folder and the 6 categories under each folder. That means that we'll have, after this step, 6 categories, 6 folders under training folder and validation folder, and of course all these 6 folders will be empty. So let's run it. We can see that these are the 6 folders from the original dataset. as written in the remarks, this code will only run once, since it's creating the folders, and it's only necessary to run once. So this will be our train data folder. We are going to create it under our chessman image dataset folder, and we're going to do it to our validation folder as well. So basically, after this code, we will have two empty folders, one named train and one named validation. Okay, next we are going to create folders for each category. That means one for the bishop, one for the knight. So please follow it. It's a very simple code. We're going to duplicate it 6 times and change the name of the variable and the name of the folder, of course. The same process will be for the validation folders. That means each of those 6 folders will be created under the validation folder as well. So we are ready to run the code, and you can see that we have created 6 folders for train and for validation. Of course, each one of them is empty. So now let's create our second Python program, and this program will copy the images from the original dataset to these empty folders, and we are going to split the data, shuffle the data, and basically 85% of the data will go for the train folders and 15% will go to the validation folders. So I'm creating a variable, call it a split. It will be the 85%. And since it's going to run 6 times the copy process, so let's create a function in order to reuse our code. So we will call the function split data, and the function will have several arguments. Source will be the original source of the folder of each category. Training will be a target folder for the training data. Validation will be a target folder for the validation data, and split size, it's our 85%. So we are going to build an array, call it files, and we are going to append each of the files, each file into this array, and then we are going to split the array. So first we are going to write a simple for loop, and just to see that we can extract, or we can read the name of the files of all the images. So let's copy our bishop original the directory, So basically, after running this function, we are able to see the names of the images in this folder. Okay, good. And this is the images, of course. Next, we are going to do a double check if the size is more than 0, just to validate it's a good image. And if it's more than 0, the size is more than 0, we are going to append the name of the image into our files array. And if not, we are going to show an error. Let's print the length of our array. We have an error. Okay, we have some syntax error. Since it's like a freestyle coding, it may be some error, so I fixed it on the fly. It's very important to add the last slash in the name of the folder. So now we can see that we have 87 files. So our function works good. Let's continue. Now we're going to do the split process. So we're going to duplicate it on 85%. The validation will be, of course, the rest. And then we are going to extract it from our array. Array has the 100% of the file names, so we're going to use our array as the input for the copy. Before we are going to shuffle all the images randomly. And then we are going to copy using the shutil library. Now we are running a loop in our train set, getting each time in the loop getting the name of the file, creating a destination. Of course, training is the destination and the validation will be afterwards another loop. And we are going to copy the file. So we have two loops, one for the train set and one for the validation set. So the function is ready. Now we are going to run the function 6 times for each of the category, since each category has its own original folders. The last character of the slash after the bishop is very important. Don't forget, don't miss it, since it will not work without this slash. So now we are getting the names of each folder, creating a string variable for each of the source, train, and validation directory. this section is activating our function. Of course, we have to change the argument for each of the categories. And now we are ready to run it. So we can see the log, and if we will go to our folders, you can see that our trend folder has images for each of the categories. These are 85% of the original dataset. And now we will see our validation folders, and you can see that 15% of the images were copied to our validation folders as well. So good, we can now start our model, our CNN model. So we will create another Python program, call it build the model, and start with the import of the relevant functions and variables. I'm going to import all the relevant, or maybe the most common function. I don't know yet if I'm going to use all of them, but first of all I'm going to import it, and then follow the process of building the model, and we will see which one of them we are going to use. Our model will be based off a square image, 256 on 256, and our batch size would be 32, and I will try 100 epochs. Of course, you can change it with your own machine if you have less or more memory. So first of all, let's write. This is our training directory, just to see that I didn't have any syntax error or any other problem, that I wrote the exact path. Now our number of classes will be the length of this directory. Since we have 6 folders, the value should be 6. It's relevant for our last layer in the model. Okay, let's run it. It should be the value 6. Yes, okay. Let's continue. So now we are going to do data augmentation in order to create more data. So we're going to load the data and to do some twisting, like resize, rezoom, reshaping. So if you're familiar with data augmentation, it's a standard process. We are going to rescale the data between 0 and 1. Since this is RGB values between 0 and 255, we are going to divide it to 255 for values to normalize the data. We are going to rotate it on 30% to do some zooming and do horizontal flipping. This is a standard process in order to create more data for our model, since we have several hundreds of the data. Then we are going to use the function flow from directory in order to load the images to a dataset. So we are going to pass our training directory, the batches. It will be divided to batches of 32 images in each batch. Of course, it's a categorical. We have 6 categorical, and the target size will be this 256 on 256. Okay, let's run the code to see that we don't have any syntax error. Okay, it's loaded 465 images that are divided to 6 classes. Okay, now we'll go to the validation. The validation doesn't have to go through a process of data augmentation. We don't have to twist the data. We just have to rescale it between 0 and 1. So we are going to run this image data generating and to do the rescaling. And afterwards, we are going to use the same function flow from directory and to load the data, the validation data, to our dataset. Okay, let's run it. Okay, we have 86 images that are divided to 6 classes. Okay, since we are going to run through 100 epochs, we would like to add early stopping, and we would like to add at advance the name of our file name for the output of the model, that each time that our training will go better and better from the previous epoch, it's going to save the new weights of the model. So we are going to define this early stopping function with the patience of 5. That means if 5 epochs there was no improvement, it will stop. And next we are going to define the name of our model. I will call it chess-model.h5. And next we are going to do all the setup for the model checkpoint. We are going to follow the validation accuracy. It will be our parameter for improvement during the training. Okay, now let's define our model. Of course, it's going to be a sequential model. And now we are going to define the layers. First one, it will be a convolutional layers of 32 filters. Activation relo, it's a common practice for activation function, and the input shape will be our 256. And next we are going to do a max pooling based on 2 on 2. Now we're going to add another convolutional layer of 64, and please follow the next step. We are going to add some more layers and to add more filters. These layers were tested, so basically I ran it about 10 or 20 iteration until I got this type of layers. And now we have to flatten the neurons, and then we are going to add layers for dense layers, the fully connected layers, in order to get the relevant or the predicted category. The last layer, of course, will be our 6 categories. So we add the num of classes, which has the value of 6. The activation will be softmax, since we would like the information, we'll get the prediction between 0 and 1. And now let's print our model summary to see that our layers were built correctly. Now we are going to compile the model. We are going to use the Adam optimizer, and we are going to add the loss function of categorical cross entropy, and we are going to follow the accuracy of the model. The Feit function is the training function. We are going to pass the dataset, the trained dataset, of course. We are going to pass the number of epochs. We are going to run it on 100 epochs. And the validation dataset, of course. We are going to add our callbacks in order to do an early stopping and save our best model during the training. In the end of the training, we would like to display, we'd like to show our accuracy versus the validation accuracy, and of course the loss. So please follow this code. It's displaying, drawing a chart of all the epochs. Okay, we're done. Let's run our code and the model will start training. This is the first epoch of 100. Now it's the second one, and we are not going to wait 100 epochs, so I will do a fast forward for the last 5 epochs and we will see the result. Okay, if you're looking at the diagram, we have about a 70% validation accuracy. It's not the best model, but I think it's good enough to display or try to predict our images. So now we are in our last step. We will create a test or prediction a Python code. So I'm just looking to see and find our saved model, and now we will start our coding. So we only need one function, the load model from Keras, and we are going to look for some images in Google, random images. First of all, let's write a classes array that it will contain the names of our classes. We will use it later in order to display the name of the class. We need also from the image object of Keras, we need the load image function and the image to array. I will explain it later. Now we will look for some images. We are just looking for chest night images. This is, for example, a queen. I'm trying to download it. It's not an image, so let's look for another image, a random image. Okay, that's good. The dimension, it's not relevant since we are going to convert it to our dimensions. Now let's look for a chest night. Choose a random image. This is look nice. Let's copy this image, download this image. Now let's look for another image for a rook. Choose one. Please look that I'm choosing images in different color and different background. Okay, let's copy these images to a new directory. I'll call it a test directory. And we will try the images to predict the name of the class to see if our model is working. So first we are going to load our saved model. Okay, and in order to figure out if we load it correctly, we are going to print our summary of the model to see if it contains our relevant layers. We can see that the model is okay. Of course, the model does not contain the layers, it contains all the weights after the training. Now let's continue, and we will build a function, and the purpose of this function will be to convert the images to our needs, that we prepare the image for our model. So I will call it prepare image. We will pass the path of the image. The first function will be loading the image, and during the loading we are going to convert the image to our dimensions. Then we are going to change the format of the image to an array, a number array. Use an image to array. Then we are going to add like another layer. We are going to expand the dimension to add one more dimension to our number array using the expand dimension. It will have, of course, only value of 1 since it's the first image on a 32 batch. Then we are going to divide it to 255 in order to normalize the data between 0 and 1. So let's take one of our test images. It will be our night image, and we are going to run the function just to see that it runs correctly. Let's print the shape of the result to see if we load it correctly and add our another dimension. So we are passing the path and we are printing the shape. Okay, we can see the one present the first image on a 32 batch. We have only one image, but we can send 2, 3 or 4 images to our model. And the 256 on 256 is the shape of our image. Okay, now we are going to run the prediction. And then we are going to retrieve the result array. We are going to use the NumPy argmax in order to get the highest value of our category. We are going to get the value of the highest category. So we can see that we got the value of 2. That means that since in our classes we have 6 classes, 0 is the bishop, 1 is the king, and 2 is the knight. Okay, the next phase will be showing the relevant text. That means not the index like 0, 1, and 2, but show the relevant text like bishop, knight, and queen. So now we are going to look inside the class array, look for the relevant text using our answer result. So let's print predicted, and let's print our text and run the same code again, and you can see predicted knight. That means that our model works very nice. So let's go another phase and show the image of the knight with the text as part of the image. We're going to use the OpenCV library, so we're going to add another import CV2. We already installed it in the first phase. So IamRead is loading the image, and we're going to use the putText function of CV2 in order to show our predicted class. So putText gets some arguments like the image, the text, the position of the text, the font, a color, the thickness of the font, and we are going to show the image. Okay, let's run the code. Nice. Knight. We can look at the image and see the predicted text. Now we are going to test it on another image. It's the rook. Let's run it again. Wow, works fine. Different colors, different backgrounds. Thank you. You are most welcome to subscribe to my channel. Bye bye.